28 students over there. There are others in wait for some time.
Hello everyone.
Students already 9, 10, and only 85 students were there. We can wait for 5 more minutes. Ask your friends to appear for the class. So after that we can start. When it comes to 100, we can start the class. Guys, we can start the class and ask your friends to appear. Nearly 25 students are missing. Ask them to appear for the class. Otherwise, attendance will not be given. And one announcement here, as we discussed before, we for this subject we are not going to have a project. Instead of that project, you'll be having a continuous assessment test 4 as a practical exam. In that practical exam, you will be having a code examination. Each and everyone will be given a separate program version. You need to write the code and provide the output for that. That instructions will be given later for CFO. And as of now, you don't need to prepare for your review presentation. That thing you can do during your project phase. Currently, you can concentrate on the course content only. And as I told before, today we are going to start the memory management. And before that, I would like to deliver a class on zombie and orphan process as requested by some students. They need a clarification in that topic. So today morning session, I will again take the zombie and orphan process. So if you have any doubts, you can clear it now. Before you might have some doubts, you can clear here. And I will give the presentation and also the code implementation. You will get a clear view about the zombie and the orphan process in this session. Students, is the presentation visible? Yeah, okay. We can start with the session, and before the session, I would like to start with a story which you know. I want to know what the zombie means. Do you have any idea what is zombie? Of course, directly before going into the topic, I would like to extract some ideas. What you know about the keyword zombie and orphan. Living but no use. Don't go in depth. You can speak actually what you know about zombie. You might have seen in many movies. No, zombie. In that case, only I am asking. I would like to ask Santosh Prasad. Human plus animal, Shiva is told, okay. Brainless, Shiva, undead, okay. Santosh, are you there? Santosh? Yes, Shruti. Shruti, are you there? Guys, respond to me.
Yes, sir.
Okay, what do you know about zombie? How you came across the word zombie in your life initially? Not now. In movies, how you saw the which made you to think it is a zombie? What it does towards the main character of the zombie?
They are in human form, but they don't have this emotion. Like they are brainless maybe.
Great.
They act like any.
They have different character, right? Which is useless and it is negative, right?
Yes.
Okay. And Thiruvanagaram have stopped the screen sharing for some time before I need some interaction before the session. So when I stop the presentation, I will start with that. Okay. And what is meant by orphan? Shruti, thanks for your answer. And Ashwin, what is meant by orphan? Ashwin? See, I'm not asking any technical questions. It's just an ideology. I'm asking you what type of ideology based on what. Okay, actually, you can text itself what is orphan. Bharat Kumar. Bharat, are you there? Okay, I will go into the topic since who is responding. I would like to say a story, so they ask. Okay, that's fine. Gayatri, are you there? Gayatri. Once without parent is Ashwin. It's right answer. A person who is not having a parent is known as an orphan. And Gayatri, are you there? Ashwin. Yeah.
Sir.
Okay. Gayatri, have you come across the word zombie and orphan?
So zombies are seen in movies, sir.
Okay.
Orphan means someone without parents.
Someone without parents. Okay. And how come it is related in this concept in parent and child, the zombie and orphan? How come it is related? Because the zombie and orphan is parents and child's support, right? It's one of the problem solving technique, zombie process.
Yes, sir.
How come it is related? Do you have any idea?
No, sir.
No. Okay, thank you for the answer. I will tell the answer. Okay, you can mute yourself. When parent and child is here on zombie process, if a child became an orphan, when there is no one to take care of that child is considered as an orphan. At which situation, if the parent is not available, the child is the orphan. If the parent is died or killed by some external source, the child become orphan. Okay. When that child is not having parents means it will not be taken care of anyone else. It will be individually separated from the society. So, one second. Individually separated from the society, what it happens means it will not go in a right track. It will be having some deviations. So no one will take care of it. You can see many movies in many heroes will be orphan. He will be going in a wrong route. So no one will be taking care of that person. So something wrong happens because he will become a wrong person and he will create a wrong society and he will be create a trouble to someone else. Okay, that is zombie. Here, that is considered as a zombie. So what if the parent is there, the child will be taken care. Okay, and they'll show him the right direction, give him the good education, and it will be in a smooth way. Okay, when parent is not there, the problem occurs. Here, the concept is this one. If parent is not taking care of the child will become a zombie, and the zombie will affect the system. Is it clear? Shruti? Shruti, is it clear? I want someone to respond. Otherwise, I want to go to further topic because guys, you're not clear about the topic. I want to know you are clear or not. I will ask Jagannath. Jagannath. Jay Surya. Yeah, Jay Surya, are you clear about the concept? I'm not asking about the technical concept. Overall, in a keyboard wise, what I have told you now, is it clear? Zombie and orphan. Yeah? Okay. How the zombie is created in a scenario? If there is no one to take care of the child,
it will be affected and become a zombie.
Yeah, that's it. That is a small concept. We are going to work on it to come up with a solution for the parent and child problem in this operating system. Okay? And thank you. Thank you, Jay Surya, for the response. Now I will start the presentation. Okay. Zombie and the orphan process. What are the terms? So in this presentation, what we are going to see is what is a zombie process, what is an orphan process, how to kill a zombie process, side effects of zombie process, and example using C code. Okay. Four important systems calls. Before entering into the process, we need to know about the four system calls, because here the zombie and orphan process happen inside the operating system. Inside the operating system, so we need to know some key terms. So what are those key terms? Are four. What is four means? It creates a new process. So initially we need a process. So that process is created by the four. Then exec. Exec is nothing but replaces current process image with a new process. So if you are having already if you are having one identity means it will remove all the information in your identity and it will give you a new identity with new informations. If you are having old data address in your ID card, everything means everything will be cleared. It looks like it will remove everything from you and put new type of identity and information for you, and it will release. That is called as the exec. It is nothing but a replaces current process image, entire image, with a new image. In this place, image doesn't means the image. Okay, image means it is the appearance of the data. Okay. Here, third one is wait. Used by parent process to wait for child completion. So here in this process, wait function is used. Okay, for what wait is used means parent is waiting for the child's completion. Here waiting is very much important function. You just system call. Sorry, wait function. Wait is a very important system call. So you should use wait in this process. And excite is to terminate a process. Obviously, if the new process is created, means it will do some operation inside it and it will excite. That is, excite is used for the termination process. This is the workflow of the process. As we discussed in the previous slide, fork will create a new process. So, what fork will do means it will create a parent process, and obviously it will be creating a child process. Parent process will be having a PID. PID is the process ID. It will be greater than 0. Okay. Parent will be having a greater than 0 and it will wait. For what the parent is waiting, parent will be waiting for the child, because child will be having a process ID is equal to 0. It will undergo some exec operation. After that, it will come out as some result. It will excite and it will come to the wait process. So parent what it will do means it will do some changes in the child process and it will continue. The process will be continued. Here the process, the operation happens here is the process creation is happened, and the for what purpose the process is created. Before going to the process, what is happened? It is the middle part. From the creation part to the processing part, it will be in the middle. That is the workflow. So, for example, if a parent is coming out of the home, here the process is created. Parent is coming out of the home, and child is also coming out of the home. Parent is skilled, so he can prepare himself and he will come outside and wait for the child. The child will get ready for someday. Okay, preparation for coming out. The child will cannot dress properly. It cannot tie the shoelace like that. Child doesn't know to comb the hair like that. Okay, child itself prepare itself, and some execution process will be happening. This execution we can keep it as a child preparation while coming, getting ready. Okay, while going out, the child is getting ready for something. Okay, that process is happening here in the execution. After this exec command, it will come outside and excite. The process is over, the child is excited of the home, and the parent is waiting for the child. Okay, where the child is coming. The parent is watching over the child. What type of appearance you tucking properly, tie your shoelace, comb your hair like that. Parent is doing some changes over the child. After changing, making the child as a perfect preparation for some function or meeting. After that, parent is continuing the process to move on to the other step. This is the actual process. Is it clear? Guys, is the process creation workflow is clear? Do you understand this? Okay, we can move on to the next slide. In this, three cases are there. In zombie and orphan process, three cases are there. What does that mean? The three cases are the parent wait for the child, parent get kills before child terminates, parent does not wait for the child process. So, in this workflow, three cases will come. First case is the parent wait for the child. Here, as usual, the parent will wait for the child. This is the first case. And the parent gets killed before the child terminates. So here some waiting time is there. See here also some waiting time is there. Here waiting time comes under the exact time. Here also some time is there. Okay. Here if the child is coming here, the child processing time to execute is 60 seconds and the parent waiting time is 30 seconds. Before the child terminates, the parent will terminate. Or it will not wait, it will go. So the child will, after the 30 seconds, if the child comes out of the termination, it will be an orphan. Child parent will not be there. So that child will be an orphan and it will become a zombie. That is the second case. Okay. And third case, the parent does not wait for the child. So here there will not be any waiting time. The child will be coming in process here for 60 seconds and the process once created, the parent will go immediately for the next process without the waiting for the child process. That is the third case. So these three cases only we are going to handle inside. This covers first and third case. Okay. So, what is the first and third case? The parent wait for the child is the first case, and the parent does not wait for the child is the third case. Where we can see, here we can see this is parents waiting. Yes, no. Okay. If this is yes is the first case and no is the third case. So in this diagram, we are going to speak about the two cases. Okay. Child termination flow. All resources are free except PCB. What is PCB here? I would like to get answer from the students. What is PCB? We have seen in the previous sessions. Okay. What is PCB? Do you have any idea? Randomly, guys, please answer.
Printed circuit board, sir.
No. If you type PCB in Google, it was the first appearance of the in IoT, but it is not IoT. It is the process control block. We are dealing with the completely process here. Okay, it is process control block. Yeah, data structures, fine. And if it is a process control block, what is process control block? Can I get the answer from you? What is process control block?
Stores all the information about the process.
Exactly. It will store all the information about the process. Okay. If a process is created by the phone, okay. So what are the things it will send with the process? If a product is released, that product should have the unique idea and it should have some content. Okay. So likewise only the fork will release parent and child with the individual ID. Parent will be having a PID and process will also be having the PID. So PID will be same. And obviously if PID is there, it will be having a PCB. That is nothing but the process control block. It will be having the complete information about that process. Parent if a parent means it will be having certain characteristics and information. Age will be more. It knows what work it is doing. It has the capacity to understand the things. So like that type of information will be available in the PCB. For child, it will also have some information, that is a PID will be there, and it will have specific character, what type of process it is, where it is going, does it have the address of reachable address or not, what purpose it is used. Like that separate information will be available in the PCB. So all resources are free except PCB. So in the initial, all resources are free except PCB means where it happens means, see here process is created by the fork. Fork will create a new process. I have a doubt on this fork process, and I want a volunteer to answer me before asking the question. Can anyone appear? It is a very simple question. I want a volunteer. Anyone come? Because I'm presenting, I couldn't see the name list. So when I'm asking, and if I minimize the slide list, the appearance will be less. Anyone come and want to answer this question? It is a very simple question. I will ask. It is not technical. Guys, or else I need to call someone else. But guys, please answer. Anyone? Okay. If fork is producing two types of process, one is parent process, child process, will the process will have the same type of data?
Yes, sir.
Are you sure?
Initially, it will have the same type of data, sir. If there is a change in mean child process, it will change only locally. It will not affect the entire data.
Okay. So if fork is producing the data, the parent data and the child data will be having the same characteristics and same information available in both, but the process ID will be different, right?
Yes, sir.
Okay. And how it is changed as a child process?
Pardon, sir, again?
And how it is changed, the process will be changed, the information inside the child will be changed. At which case it is changed in here, in this case?
If you use pointers, sir, or cache memory.
Oh, no, I'm not asking about that. Okay, thank you for the answer. I will tell the answer. Okay, thank you. And your name, please. I couldn't see your name. Can you share your name? Shivan. Thank you, Shivan. Thank you for the answer. And I will tell them. The data created by the fork for the parents and child will be the same. While coming to this exec operation, what it will means, it will completely clear the data that which is available in the child process, and it will give all new information to the child and freshly, because the parent will have some experience, child will have zero experience. So what it will mean, except will clear everything and fresh, everything is fresh. Fresh information is fed into the child, and it will produce the termination, produce the child to the termination operation. Is it clear? Likewise, only the child is created in this exec operation. Before exec operation, the parent information and the child information both are same. Only the process ID and the name will be different, but the characters and everything will be same. So likewise only, all resources are free except the PCB. Even though if you change the informations, the process control block information will be residing inside, so it will not have a separate memory or CPU. It won't have any other resources like CPU or memory. Okay, everything will be freed and it will have some minimum information only, that is process ID and PCB. That inside PCB also nothing will be there. It will be having some information about that product and it is very less memory consumed item. Okay, so all resources are freed here and child enters here to the enters the zombie state. Whatever the child it is, it will after the execution stage in this place, it will enter into the zombie. So you think about a child, it won't go, without proper education or instruction. If no, there is no one to guide, means the child will not go in a right way. Okay, first of all, it will do the wrong things. If we tell the child not to go across the road, means it will run immediately. Okay, it will do the wrong things which it doesn't know. Okay, it is a child. It doesn't have that much awareness and education. If he does the good things also, it doesn't know it is good. Okay, like that only here the child process will be there. It doesn't know anything. So by default, the child will enter into the zombie state. Okay, so what happens is the parent waiting. So is here the zombie state will be entered and terminated. Okay, now the child is coming out of this execution as a zombie. So when it comes here, wait, the parent will be waiting here. If child is a zombie, will the parent leave it as it is? What is the work of the parent? The work of the parent is to resolve that problem which is in the child. Okay, if the child is mentally affected, means the parent will educate the child to come out of it. If the child is health-wise affected, means the parent will take it for the hospital and take care of its health, and they will clear all the problems for the child. Like that only, here the parent also. If the child, so if the parent does any all good things, means it seems that parent is waiting. So if the parent is waiting, what will do? The parent will ask the PCB to clean up the PCB. And if the parent is not waiting, no, child remains zombie. It means, so the parent is seeing the child is zombie, so parent take care of this that zombie child. What it will do is, it will request the kernel, because kernel have the control of the PCB. Whatever the changes will need to be done in the process control block, it can be done by the kernel. Okay. So what the parent will do is, it will send a signal to the kernel to clean the PCB. If the PCB is cleaned, the child will be clean and the zombie effect will be removed from the child. Okay, so the parent is, if the parent is waiting and the child is terminated and coming to the parent, means the parent will request the kernel to clean the PCB and the zombie effect will be clear if the parent is not there. So what it happens? The child will remain in the zombie state till the end of the process. So what it happens, if there is no one else to take care of the child, it will be going in the wrong way. So likewise only, zombie state is there. Till the final stage, it will be in the zombie state itself. Okay. In this, we have covered the case 1 and case 3. And what about the case 2? The case 2 is parent gets kills before child terminates. This killing may happen automatically or by some external force to affect the system. May happen. Okay. First of all, here the zombie state occur, and the solution for the zombie state is the parent should clean up the PCB. So zombie, a process which has completed its execution but still has an entry in the process table, that is called the zombie process. Means the example is below. Process ID is there, PCB is there. Each and every process after the completion, it will be having the process ID and PCB. So likewise, it will be having this content only. This content will not affect in any way the system, because it won't have that much resource in it. So the process ID will not consume that much memory, and process control block it will be having some information that is very minimum, which has very minimum level of memory. Okay. So what it will do is it won't have any other resources like CPU memory, hence the zombie size will be very minimal. And the solution which we took in the previous step is parent will ask the kernel to clean up the CPU. Okay, if the zombie is here, the parent will clean up the CPU, means the new process ID will be created and the PCB will be cleared. And this type of process is what process is happening here is reaping the child by the parent. So the process where the kernel is requested by the by the parent to clean the PCB, it is known as the reaping here. Reaping the child by the parent. This solution is named as a reaping. For zombie, the solution is named as the reaping. Reaping is nothing but cleaning the PCB. Okay. And orphan process, where the orphan process occurs, it occurs in the case 2. Okay, what is the case 2? Parent get killed before the child terminates. Oh my god. If the child is coming out as a zombie effect, and at that time if the parent is not available and it is killed by someone, means that no way the child will still remain in the zombie state. So we can see the flow of the work, what is happening here. The parent waiting for the child to get the complete. So if the parent is a good parent, it is waiting. Before the child completes, this parent was killed by the external force. If someone is trying to break your system, or any internal attacker may be in the system. Okay, so here there is no wait system called. That wait system called is not there. When the child comes out, it will be excited and it will be in a zombie state. And obviously, if the parent is not there, the child will become orphan. Okay, this child will remain as a zombie forever since it doesn't have any parent to remove the PCB. So till last, the child will be remaining as the PCB. For example, we can take the robo movie. Okay, in the robo, Rajnikant will be having a chip. In that chip, blackboard will be there. Blackboard, it seems that some negative power will be there. Okay. If there is no one to remove that chip and reprogram that robo, it will be a very big disaster. That was the concept to the like same way only. If no one is there to take care of the PCB content, to clear the content here, the child will become orphan and it will remain in the zombie state. So here it comes inside the orphan process in case 2. So what is the orphan process? A process that doesn't have a parent is called an orphan process. What is the solution is the kernel will give other new parent to the orphan process. So it is nothing but adopting the child. Okay. So the kernel is the control for everyone in this parent-child process. In the orphan zombie and orphan process, kernel will be the deciding authority. We can take a kernel as the governing or decision-making authority here. Okay. So what happens is the child will be an orphan. So once the child becomes as an orphan, or the parent is not responding, or parent doesn't have any waiting time, or parent is not available, by checking these cases, what the kernel will do is to protect the child from entering into the zombie state. And before entering into the orphan state, what the kernel will do means the kernel will allow a new parent for that child. Okay. So that new parent will wait for the child completion, and after that wait, the child will be coming to the new parent as the zombie, and the new parent will take care of that zombie child, and it will request the kernel to clear the PCB, and the zombie will be killed at that time. So this is called as the reallocation. So first process, it is a reaping process, and here reallocation of the parent. So what will be the next parent for the child? What will be the next parent? It will be the init process PID 1. Init means it is nothing but the initial. initial process. For every process, there will be initial process that will start with 1. So only the process ID is given as 1 and it will be initialized. So it is named as the init process. That init process will be allotted as the new parent process child. See, once the imagine it as a tree structure. I will show the pictorial representation also. If the child's parent is killed, the chances for that next parent will be in the upper tree. Okay, but that upper tree cannot be allotted as a parent for some cases. That case I will tell you in the further slide. Until is it clear? Orphan process, reaping and reallocation. Guys, please respond. Is it clear until now?
Yes, sir. Until now, I am clear, sir.
Sorry?
Until now, I am clear.
I couldn't get you.
Clear, sir.
It's clear? Okay. Okay, next, as I told you, as a tree structure, T diagram of the new parent allocation. So, as I told you, this is the master parent. Now, master means from this only, every parent and process is clear. See, for if it is creating a process, means that process will be having a unique ID and it will have some child. And likewise, this tree will be growing, the complete tree structure will be the data structure. Okay, one and one is linked and the process is going on. Okay. What happens here is, if the process init is here, P1, C1 and P1 is the parent of C1 and C2. Here it is C2 is hidden, here it is C2. Okay. So what happens is, C2 will be having a child. Unfortunately, if C2 is killed by some external force, means what the system will do means, kernel will do means, kernel will be trying to connect this D1 with the P1. At first, the kernel will try to make P1 as the parent. If it fails, init will given as the parent for D1. Okay. First of all, it will try for the nearby ones. So the problem here is the nearby ones will not accept it because it already has the child. It already has a child. It doesn't have that much open mind to accept a new child which is not originated from this tree. Okay, so it will not accept it. But if in some cases, if it accepts, means the kernel will allot it as a P1, but it will be maximum init only will be allotted as the new parent for the zombie child, whose parent is killed. Okay, so if for in this case, the new parent for D1 is init. This process is called as the reparenting, finding another parent, parenting for the child process. Okay. What is the difference between the reaping and the reparenting? Not a difference. What is the thing means? Reaping is the thing associated with zombie process in the first case, and here the second one, reparenting is associated with orphan process. Zombie process and orphan process are both same. Are both different, and both different things will have the different solutions. Reaping is nothing but cutting out, taking out, and the meaning is reaping. Okay, and reparenting is allocating new parent. Okay, reaping is killing the parent, and reparenting is allocating new parent for the child. And two important facts about the zombie and orphan process are: all process enters the zombie state after exit. As I told you, every child process enters the zombie state, and after the termination, it will be coming out as a zombie only. Okay. And after that, that zombie child process only will be handled by the parent after the dating stage. That is the only part of the parent here to clear the PCB of the child. Okay. Orphan process does not have a parent and it gets reparented. That is the second case. Well, obviously, orphan parent will be reparented. That is a default. Otherwise, it will become as a zombie and it will destroy the system. Here we can see how to remove a zombie process. So, zombie process removal is important. parent is not waiting for the child to get the completion. So here no parent is there, so that's why no connectivity is here. So when the child enters execution, it remains as the zombie process. This is the problem. How to remove this? There are some solutions. Kill the parent. Okay, first, if the parent is not waiting here, why this parent should be there? If it is a wrong parent, this parent should not be left here. So this parent will be killed and a new parent will be allocated for taking care of this child. So if the new parent comes here means parent wait for the child to complete. So that status will be changed and obviously the process will be in a good manner. Okay. And send sick child signal to the parent and makes the parent handle it. Sick child is nothing but if the parent is not waiting here. So kernel what it will do means it will send a signal to this parent. See, your child is coming. It is in the zombie state. So you need to take care of that child and clear the PCB. Request the kernel to clear the PCB so that your child will be saved from entering into the zombie state. And if it is in the zombie state, it can be cleared easily. Like that signal will be sent to this parent, and that parent will awake at that time and it will take care of the child. This is the second case to remove the process. So what are the conditions for the signal means? If we send the sick child signal from the command line to the parent, by default the parent will ignore the signal. But at that case, what we can do is we can write some code over the parent and make it to remove the zombie process. So at the time we can educate the parent to remove the zombie process. Here, what is the technical background behind this regression of sick child signal means every process will have the signal handler. If the parent is having it, it will be having a signal handler. By default, if any signal is given to that parent, whether it is a positive signal or negative signal, whether it is a productive message or gains for that process, it doesn't mind. By default, that signal handler will delay the signals. By rewriting the code in the signal handler, if we want the parent to accept that signal, means we need to rewrite the code in that signal handler, and we can make the parent to accept the sick child signal. If it accepts the sick child signal means automatically it will clear the contents in the PCB of the zombie child or the orphan child. So what are the adverse effects of the zombie process? It's a well side effects. If there are limited zombie processes, then no side effect is there. So how come you can find here? First of all, I will read all these 3 points. This is the end of this slide, and we can discuss about the practical availability of the zombie process in the system. Okay, if there are limited zombie processor, there is no side effects. Means why that? Why it is telling it is limited zombie process? Means if the system, I will come to the next point. Limited number of DAs are available. It is having 32768 numbers in Linux operating systems. Okay, if 32768 number of processors can be created in the Linux operating system, if I am having 300 zombie process in the system, will it cause any effect to my system? Guys, anyone please answer? If I am having 32,768 process capacity and I am having a 300 zombie process in it, will it create any effect on the system?
It will not create, sir. No effect.
Okay, that's fine. And if I am having 1,000 zombie process in my Linux system, will it affect my process?
It may affect the processor.
It will affect light effect. What type of effect it will be? Because this zombie process is not having any cruel code in it to affect our system. In which way it will be affecting our system?
New applications cannot be started, sir. New processes cannot be started.
Exactly. New process cannot be started because all the process IDs are occupied by the zombie process. If 32,000 process or capacity is the capacity of the Linux operating system, means in that if 20,000 is occupied empty, it doesn't have any work information, nothing is there. It will be having its own information related to process ID and PCB. It will not have any CPU information or disk information or any memory will not be there. So it will be affecting the process. Further process will not be, cannot be created. If we didn't notice the zombie process and it is day by day it is spreading out, means at some time it will reach the 32,000 count also will be a zombie process, and the time the process cannot be created and the system will be interrupted. So to stop that only we are going for the zombie process. Okay, and increase memory usage. And now you are telling no processor. See, process ID is filled, so I cannot create a process. Fine. And how come it increase the memory usage? Is it possible? Do you have any idea, guys? Anyone answer? How come it will create a memory issue?
Sir, as you previously taught that the parent process and the child process has some memory, so that if the number of child processes increases, the corresponding memory occupied also increases.
Yeah, of course, exactly. Your answer is correct. So what happens is, means even though if I am having uh, the capacity of my purse is 1,000 rupees, 1,000 points I can put. Okay, that 1,000 points I can put, but I am having a duplicate coin also. Duplicate coins, it seems it weight is very less, but it looks like exactly like a coin. But I am day by day I am putting one coin in my purse. Okay, even though 1,000 coins means it is useful for me. I can reuse it and spend it. I can earn it back. I can invest it. But if this dummy coins are occupying my purse, so what it happens is it will also occupy some memory. Memory means space. Space will be utilized, and because of that space is utilization, I will get a space issue there. I cannot put my original coins, which is useful product for me. I cannot use it at that case. So at that case, what happens means a memory issue there is created. Even though process ID and PCB is very less memory, when it comes to the enormous amount, it will create a very big damage to the system and the process. Okay, is it clear? And with this, it is over for the presentation. If you have any doubts in this presentation, means you can ask now itself. In between, I will have some water. The zombie process is clear for you. Okay, nice. And any other? You have any doubts in this? Okay, fine. We can go for the code implementation part. I will show you the code of the zombie process as well as the orphan process, so that you will be clear in the implementation part also. And wait for a few minutes. I will open the virtual machine and I will show you the command line in which the code is running. I need some couple of minutes to open that. Guys, is my VM box is visible for you?
Yes, sir.
So in this first of all, we need to open the code.
Sir, not visible, sir.
Now the right. Now
Yes, sir. Now
Now visible, sir.
okay. I want to maximize the screen for you, so I went into the full screen mode. So if I went into the full screen mode means it is not. Guys, if anyone can record this demonstration means you can record it and send it to me so that I can upload it in the Google Classroom, because I am having some trouble with recording. If I am entering into the virtual box means it is going outside. So can I record this? Anyone? Who will take care of this?
I'll do, sir.
Okay. So from this we can open the what are the process codes inside my VM box. I will often on Zombie. I have already written this course, this code. So we are going to open. So what is the code? This you can find a simple code for the zombie in which a process is created using the fourth command, and the process ID is greater than 0 as we saw in the block diagram. Here the sleep timing is fixed to 50 seconds. I'm sorry, 50, it is 50 seconds. Okay. Sleep time is fixed to the 50 seconds, and the child excites before the parent becomes excites before the parent and becomes zombie. This is the condition given in this code. Are you clear, guys? Is this code is clear?
Yes, sir.
yes, sir.
Okay. So I'm going to compile this zombie. Like no error is there. And in order to run this code from the kernel, I need to give some different types of commands. Okay, here we are going to handle with the process which is running behind. So what we need to do is we need to give some different process commands. It will initiate with PS. Okay, so that process commands you can find in man PS. If you give the man PS means it will show different process commands that you can use it. But initially, at the end of the session, I will give you the library code, I mean the command description that you can find all these commands. But if you are not aware of it, at this time you will maybe have some confusions. I will clear at the end of the implementation. Okay. This, as usual, same output command we are going to give ./a.out. And to run this command in the process side, we are going to add the and symbol. So here, what process is currently running means the process number is 1 and this 2171. So what I'm going to do is I'm going to see the tree structure of this process, so only I can find the child of this process. This is the parent process. So for that what command I'm going to use is PS tree. PS is nothing but process and tree and minus P, and I'm going to type the process ID 2171. So here the parent process is 2171 and the child process is 2172. Okay. So now what I'm going to do is I'm going to check the status of the child, whether the child is a zombie process or the normal process. So for that, what a command I have is I have a PSAX. PSAX is nothing but to see the status of the process. See every process on the system using the BST syntax. It will be named as that, and that description I will give you later. And PSAEX and grep. I'm going to use the grep keyword. This grep keyword is used for searching in the process list, and I'm going to search the child. What is the status of the child? So I will fix 2172. That is the child process. So here, the child process is here, and its status is done. I will run this again. And for your information, if you're checking the status, or I just explained to you and started this execution. So here the output is not proper. It is time constrained output. If you want to see the zombie process immediately in this implementation, means each and every command should be given immediately. So I will come again from the first process. I compile the zombie. I am taking the output of the zombie, and this is the code of the parent. And we are checking the tree 2193. It is 2194 is the child. So what I will do is 2194. I'm checking the page. See here. 2194 is a zombie here. Is the zombie code. So till the parent change that, the zombie code will be repeating. You can check it again and again. So if I keep on implementing it, at a certain stage, the zombie will disappear. Because here the parent is waiting and it will change. Okay, it will keep on going, and some stages, after some time, the 2194 stage zombie will disappear. Are you clear? Because at the previously I did the same type of command. What happens is here the zombie state was not there. Okay, and the child is this child is disappear from the zombie state. But immediately after running the codes, I got to know the zombie state, and now I will try. See here, the zombie state is out and it is done. That's all. Wait for this. See here, the Z disappears. So the parent convert the child reproduct. Here the reeking process happened and the zombie is removed. And the 2194 is the child, which is clear. Are you clear with this code, guys? Is it clear? Okay, and we are going to the next code, that is orphan. This is the code. In this you can see the same for command we have used for creating, and the process ID is there, and the only difference from that and this is here you are going to put excite command, because here parent is not going to wait for the child. Parent process excites before the child. So I'm going to put an excite system call here, and after that child will sleep for 60 seconds, because child will, there's no one is there to take care of the child, and it will return 0 and it will proceed. Is this code clear, guys? The difference between the orphan and zombie is this one. Okay, the excite will be for the parent, and the child will get the sleep system call. Is it clear? Can I implement this code? Yeah, I'll implement. What I'm going to do is I'm going to put PS3 here. I'm going to find the parent history. This is the because here no child is created here. Parent is there, child is not displayed. So I want to find the child. So what I will do is I am going to search the child. So what I will do is, because parent is not waiting, so child is unknown here. So I will run this command. I'm going to grep, likewise psaex grep. I'm going to find, how can I find the child without knowing the process, I mean process ID of the child. I can write simply a dot out. So it will display me the child. A dot out. The child number is 2251. Okay, it is 2250 is the parent and 2251 is the child. So now what I will do is, now I will enter the PS code here. PS minus 0 parent ID equal to, I want a new parent. Reallocation happens here. I want a new parent for this child 2251, because this 2250 is not taking care of 2251. So only here it is empty. So I am going to put the reallocation here. So reallocation is done for the 2251. So I want to see the status of the process, which 2251 is allocated for which parent, what is the new parent ID for the 2251. I want to check, because new parent ID is necessary. I will click one. So this is the tree structure. In this, you can find the 2251 is the child ID. You want to find the 2251 where it is there. Here it is the init parent, that is 1. Okay. Under this subdivision only, 2251 will be here. You can find it easily. Where is it? Oh my God, it is very big, so it is difficult to find the child ID. So obviously that 2251 will be the child of the 1 only. Okay, is it clear? It will be inside this tree structure. Because of the screen is very minimized, I couldn't find. Is it clear, guys?
Yes, sir.
Is the zombie and orphan process is here? In this process, what happened is reallocation happens. In that programming, reaping happens. Okay, are you clear? Is the topic clear now, guys?
Yes, sir.
Okay, that's fine. And I will tell you the description command to find the process description commands. So that you can find the process descriptions commands. Still, I'm trying to find the process inside it. Yep. Here 2034 is here. I will show the description. This man ps is the command. When done, here you can find the entire description of the user commands for the process. PS is nothing but recording the snapshots of the current processes. Okay. This is the commands example. See here. To see every process on the system using standard syntax. These are the standard. Every process you can see by implementing these commands. In your free time, you can check all these commands and check the status of your systems. What is the process number? What is going on? In this, you can see to see every process on the system using BSD syntax and to print a process tree. As I printed it before, PS. One tree process tree appeared, and that I was trying to find the number of the child process, where it is appeared, in which tree is there. Like that, you can see the structure of the tree, information about the threads. As I told you, in Windows, for seeing the thread in the second assignment, we used the process explorer to see the thread structure. Here, you can use this command to see the threads in the process, security informations, and see every process running on the root. Like this, many things is there. You can try this. It will be useful for you, and you can explore new things. Because these informations will be residing in the kernel only. So you might have not explored these things, okay? So you can try this. Main command is man ps. You can try this, and you can use it for some other purpose. Is it clear, guys?
Yes, sir. Yes, sir.
Okay.
Sir, I'll send to you after the class, sir. The recording.
Sorry? Come again, can you tell us again? I couldn't get you.
Recording can I send after the class, sir?
What video material, right?
Yes, sir.
Recording.
Yes, sir.
Yeah, obviously now you will be having half an hour break. That you send it to me, okay?
Okay, sir.
You have my mail ID. You can if it is consuming lot of space, means you can compress it or you can upload it in file and share the drive to me. I will download it. Okay.
Okay, sir.
And now you can go for. And before that, I would like to get a feedback of this particular session because I worked a lot for this presentation. Everything. So is it clear, right? I want feedback. Yeah.
Yes, sir. Yes, sir. Very clear.
Okay, thank you. And Exactly. No, no, I will not take too many time. I will exactly ask to 4 or 5 members the feedback, and you can go for the break and come at 11 o'clock. Vimal Rajan. Vimal Rajan, are you there?
Yes, sir.
Do you have any doubts in this topic, in the implementation and the concept? Do you have any doubt?
No, sir.
Okay. Is it clear? That's fine. And obviously, because I'm not getting some students are not at all responding, so I would like to speak with them. Yashwant, are you there? Yashwant? Yashwant?
Yes, sir. Yes, sir. I'm here, sir.
Okay, are you clear? This topic is zombie and
Yeah, yes, sir. It's clear, sir.
Okay, that's fine. And what I would like, apart from this zombie and process, I want you guys to explore the process commands, because not only you got to know that idea how to give this work to you. You can open that man ps command. As of now, you can implement any comfortable basic process commands or anything. 20 numbers. You just try it. I'm not fixing it. Okay. You just try the command, and you see the output of your own system process, how it is running, so that you can take the screenshot and submit it as assignment. Are you able to do this thing? Because it doesn't comes under your curriculum, but it will be useful to, at least for this assignment, you will try those concepts. Are you comfortable doing this assignment?
Yes, sir. Yes, sir.
Okay, guys, if you have any difficulty in doing this assignment, because already I have given you the description and the command is there, you're just going to run those commands. Okay, you just try on it, and let us fix it to 30. 30 process commands. This is the task for this work, and I'm not going to fix any time for it. It depends upon your own interest. I will just, for namesake, I will give one day time. Okay, and you can submit at any time. I want you to explore different types of process commands in this Linux platform. And someone told that you are having the IoT for the, which is used for the Raspberry Pi, and I ask you to install the Ubuntu Linux in your system. So it will be useful for you in many ways, but Raspberry Pi is purposely used for that purpose only. But in Ubuntu Linux, you can develop a huge number of things, and you can learn many things in Ubuntu Linux. So you download Ubuntu Linux in your system. It is openly available. Latest version is there. Its memory is very less. So try with desktop operating system Ubuntu Linux. Don't go with Raspberry Pi only, because it has a very less memory, and the specifications are very less. Okay, you can use version. It is already available. If you don't have the link, you can ask me in the Telegram. I will send you the link separately. Okay, everyone knows that. But if you want, I can send it separately. Okay, and thank you for this morning session you have been attending. And if you have any doubts, because I don't want to keep you back before the break, I would like to ask the questions also. But I'm sure that it is clear to you guys. And come back after half an hour, 11 o'clock, we can start the class again. In that, it will be, I will be speaking about the memory management. It will be a smart board will be there. So I will try to give my best handwriting in the board. Okay. Thank you. Come back exactly at 11 o'clock, and you should be at 11 o'clock, because at that time Professor and Prema ma'am will be there to meet you. So be on time. Okay. Thank you.
Finally, Ubuntu. See.
Good morning.
Good morning, sir.
How are you all doing? You can hear me okay?
Yes, sir, it's clear, sir.
Okay, thank you.
Yes, sir.
Good morning, all of you. I hope I can, I hope you all hear me. This is Professor Raju. Yeah, okay, thank you. Just a couple of things I would like to share with you. We have been in touch with your faculty mentors. Whatever input you have given them, they have conveyed those to us. So we are aware as to how things are. And Professor Prema and myself both have been talking with the professors teaching this course and also your professors who are in touch with you about how things are. Whatever feedback you've provided, and that was very helpful to react. So I've requested Professor Prabhu Kavin and Professor Shiv Shankar to make sure that whatever they teach, that you understand clearly. And they're also not going to carry with the project they have given to you. I think project is something that you can do later on when you have 2-3 weeks time frame. At this time, understanding subject matter and then able to take these continuous assessment every 3 days or whatever way they have arranged, and then taking the final examination. For me, it's extremely important that you understand the concepts and be able to use it either in this course or when you move to the next one. So please do not hesitate to give feedback to your professors teaching this course or to your mentors. And if it is needed, send me a mail or to the vice principal, one of us. We are here with you and we will make sure that if you have any concerns, those things are properly addressed. So please learn, and I'm more concerned if you have any difficulties and you don't tell us, please. We are very particular about you learning. Don't focus on the examinations or other things, what you learn, and if you can apply those. So please go ahead, and I don't want to take more of your class time. We will again come back to find out if there is additional feedback. For now, Professor Prabhu Kavin and Sir Shiv Shankar are aware of any of your concerns, and they will address those carefully and make sure to teach the things that you can understand. Thank you. Please go forward.
Sir,
Yes.
sir, Professor Prema ma'am was in the call. She joined the call, sir.
Okay.
Yes.
Prema, you want to say anything? I just basically have given my input.
Pretty much that's all, sir. So I guess we can wait for the students if they have any concerns.
Thank you, Professor Prabhu and Professor Shiv Shankar. Please proceed. And
Yes, sir.
we'll be in touch with both of you as well as with the students. Thank you very
Yes,
much.
sir. So thank you, sir.
Thank you, sir.
Students, shall we start the class? Anyone please respond?
Yes, sir.
Yes, sir.
Okay, that's fine. Today we are going to start the third module, that is memory management. And before going into the session, I would like to show you the pictorial representation of the memory manager, what is happening there. And after that, we can go for the smartboard presentation. In that, I will tell you the need for the memory management and multiprogramming, so that you will be clearly have an idea what we are going to, why we are going to solve those problems, what are the kinds of the problems, so that you will get an idea in those things. Now I will display you the video. For it will be a 8 minutes video. You just see that you will get an overall idea what is happening in memory management. Okay. Thiruvengadam, is the audio audible?
Hello, my name is Sean.
Thiruvengadam?
It's audible, sir.
And in this tutorial,
Okay,
we
okay.
shall begin with the memory manager and look at 3 old schemes of memory management. Single user contiguous was the first scheme of memory management, and it wasn't very efficient in terms of performance. A single job would reserve the entire memory space. This job would be processed, and then the memory was cleared, allowing the next job to be loaded. If the job size was larger than the space available in the RAM, it could simply not be executed. This scheme is considered impractical for today's modern operating systems, as it would be very slow to process all of the jobs on demand. But what if you wanted to store 2 or 3 jobs in the memory? This is when fixed partitions came along, allowing allocated partitions to contain more than a single job at one time. All of the partitions were stored in a partition memory table to keep track of partition usage. The sizes of these partitions were static, meaning they could not be changed, unless the system was rebooted. So you could see how this would be a problem. A dynamic solution was necessary to avoid having to reboot the computer every time you wanted to process a job. A dynamic partition's available memory is still kept in contiguous blocks, but jobs are only given as much memory as they request when they are loading for the processing. This has proven a significant improvement over fixed partitions because memory is not wasted in the partition. Unfortunately, this is not a complete solution. Both fixed and dynamic partitions need some way to allocate jobs to the available partitions. There are 2 ways to do this. The first fit quite simply finds the first partition that has sufficient storage space, not taking into account how much memory could be wasted in the allocated partition. The best fit first looks for the smallest partition, resulting in more space for other jobs. It is then removed from memory, also known as deallocation. With a fixed partition, this is fine. It is simply cleared. But when using a dynamic partition, it gets more complex to free up memory as it tries to join together adjacent blocks. So, looking at these simple allocation schemes, we can see there are still problems. Each one required the memory manager to store the entire program in the main memory at contiguous locations. We need to find a way to avoid having to keep the whole program in memory to run, and the restriction of storing the programs contiguously. What if we could divide the jobs into separate, smaller chunks? We can. Virtual memory is the solution, and we shall look at the evolution of 4 memory allocation schemes. Let us start with paged memory allocation, allowing us to divide the job into equal-sized parts. The sections of a disk are known as sectors or blocks, and the sections of main memory are known as page frames. Before executing a program, the memory manager makes some preparations. First, it determines how many pages are in the program, and then it locates enough empty page frames in the main memory so that it can pass all the pages into them. The adjacent memory blocks do not have to be loaded in as adjacent memory blocks. They can be stored in any available page frame in the main memory. Now, this is a more efficient scheme, but it does come with complications. We need a way to keep track of all the page locations, which increases complexity in the operation. Through the use of 3 tables stored in the part of the main memory, we can keep an eye on locations of various jobs. The job table is a dynamic list that contains 2 values, the size of the job and the page map table location of that job. The page map table contains important information for each of the pages, the page number and its corresponding page frame memory address. Finally, the memory map table has 1 entry for each page frame, listing both its location and a status informing whether it is in a busy or free state. Now that we have an understanding of paged map allocation, we can now see how demand paging works. It's very similar to the previous concept, but the main difference is that pages are loaded on demand, meaning that pages are only brought into memory when they are actually needed. The page map table we looked at before increases with 3 more columns. One to determine if the page is already in memory, known as the status. The second to check if the page has been modified. And a third to check if the page has been referenced recently. How do we determine replacement of pages? By using a page replacement policy. First in, first out. Least recently used, least frequently used, and most recently used are replacement policies used to change pages based on a specific algorithm. These are all pretty self-explanatory and are crucial to the efficiency of the system. So we have looked at page map allocation and demand paging. But what else is there? Well, we have looked at separating the jobs into pages. What if we could break it down even further? We can. Segmented memory allocation splits the job into separate segments that reflect the nature and structure of the code. Usually, when you view a script, it is separated into individual functions or subroutines that can be called one at a time. You may have a function called add that makes a calculation of 2 numbers, and a function called divide. We can call these one after the other, and they will run in the chosen order. Now, take all of these functions and label them as segments. Instead of using a page map table, we now have a segment map table that makes a list of all of the varied sized segments that need to be put in the main memory to process. Now we move on to the final scheme. It is a mixture of segmented and demand paging memory allocation. It offers the logical benefits of the segmentation idea, as well as the physical benefits of paging. There is no new logic involved, but there are some minor modifications to point out. It makes use of both the segment map table and page map table, plus additional information of authority to read, write, and execute a file. A major disadvantage of this is the overheads and complexity of adding in more tables to handle the load. Why is virtual memory a good thing? Well, let's say we currently have RAM that is fully occupied and has no time for jobs waiting to be slotted into it. Because we use segmentation and paging, we can exceed memory capacity by turning to the backup memory, the hard drive. And although it's a slower alternative, it can act as an extension to the RAM. We have come a long way in memory, but at an increased processing cost, the operating system can provide a more efficient service to allow the CPU, the central processing unit, to handle jobs with better time frames and effectiveness. This has been Sean, and in the next episode, we will move on to the Process Manager. Please do not forget.
Students, the concept which you saw in this video covers all the topics from the starting till the beginning. What all the things required for the memory management is shown as the pictorial representation, and each and everything consists of separate problems, and everything has a separate rule for paging, mapping, everything it has, and we will be learning such things in the upcoming classes. And now I will give you the need for memory management content through the smartboard presentation, and stay connected, and I will upload this YouTube video in the classroom link. I felt it is somewhat just fast, and it covers all the topics which comes under the memory management. So if you want to look it again, you can see the video in the course material. I will add this video after the end of this class. Now I will take the class through the smart board, and I would like to get the feedback from you. Is this video useful, guys?
Yes, sir. Yes, sir.
Okay, that's fine. I will move on to the smart board and I will start the presentation. It will take a couple of minutes. Please wait. I will connect to the smart board.
Yes, can you tell why we need memory management in this operating system? What is the necessary? Can anyone tell voluntarily, because I couldn't see the list of students?
Efficiency, sir.
Sorry, efficiency. Okay.
And also to prevent data corruption.
Data corruption. Okay, that's it. For that one, you need the memory
to avoid
management.
errors, sir. To avoid errors.
Okay. Apart from that, because for many, it has many purpose. Okay. It depends. And more than that, when we have lot of memory, it is very difficult for us to process. When some collapse happens, we may lose it, process may misbehave. For everything, for different types of problems, this memory management will give a solution. Okay. And what are the things the CPU can directly access? What are the things in a computer? What are the things the CPU can directly access? Aparna? Aparna, are you there? Yeah. Thank you. What are the things the CPU can access? It is very simple. I'm just not asking the question, I'm just interacting.
I couldn't get your question clearly.
What are all the things the CPU can access in your computer?
Execution of different process.
It's simple.
I
The CPU can access everything in your computer because it is a central processing unit. Everything is centralized. It can access anything it wants, right?
Yes.
That's what I meant. Okay, thanks for the answer. And here in memory management, the CPU can access everything. First thing is registers. Cache. main memory. Everything the CPU can access directly. There are three important memory elements. Okay, these are the three important memory elements in which you can put the data and instructions where the CPU can access only these. Okay. All these components are costly. So if you look at the register, it is costlier than cache. And if you look at the cache, it is costlier than main memory. It is nothing but RAM. And coming to the main memory, it is costlier than hard disk. And it is the secondary memory. So why cost is constrained in the memory management? Because see, if you want, if you store everything in register, you can get a 100% efficient processing or process output. And if it comes to cache, it will be the next level. And main memory is the third level, and hard disk is the fourth level. So everything is you can, if you improve the efficiency of the register, and it is not nothing but the efficiency. It means you should have the configuration, highly configured registers, high configured cache means your efficiency can be improved. But the problem is the cost also improves. If the cost improves, means it is very difficult for you to afford that system, and at that moment expenses increases, and it is a loss for a company. If a company is using such a thing, means it is a loss for that company. So we cannot go for a large amount of main memory, registers and cache because of high cost. And if we have a bigger main memory, we can load more processor, and if we have a more processor, we can run more number of processes. And in this, what we come to the conclusion means, if the main memory is high, if the main memory is high, the CPU utilization will be high. It will be 100%. But achieving 100% utilization will occur only by improving the main memory, but it is not meant that when the main memory is infinite, CPU utilization will be high. For that, I will give you one small example. So it is not meant that if you have infinite memory, your CPU utilization is also infinite. It is not meant like that, okay? But some improvement will be there, but it is not exactly 100%. Okay. We can take main memory of capacity 4 MB, and you have a process of 4 MB. What is the one process? The fraction of process time doing one process is the fraction of process time doing I/O. Then what will be the CPU utilization? So in this case, what will be the CPU utilization means this process will be the one process will be the process time. T will be the process time. So the CPU utilization time will be equal to 1 minus P. Don't think that it is entering into the mathematics formula like that. Actually, it needs some calculation for allotting the memory inside it. Okay. If the P fraction is going to be 80%, which means that process is going to spend 80% of doing the IO, then what will be the CPU utilization time? Do you have any idea? If the is going to get 80%, what will be the CPU utilization time? So the CPU utilization time will be 20%. CPU equal to 80%. How it comes 20% means here the p value is the fraction of p time. It is nothing but what will be the p value means fraction of p time means the value of p lies between 0 and 1. So it will be a point. It will be a 0 0.1, 0 0.9, 0, 0 like that. It's somewhere it lies between 0 to 1. So the CPU utilization time, if the p value, if the process time takes 80%, the utilization time will be 20%. Okay. Likewise, it will improve. And this condition, you just keeping in mind. Now I am going to increase the main memory into 16 MB. So here the main memory I have given at 4 MB. Now I am going to increase it to 16 MB. What happens? Let us see. Main memory, it is 16 MB, and each process is 4 MB. One process is equal to 4 MB. So I am declaring each process is 4 MB. Okay. Then how many processes can I put inside the memory? Do you have any question? Any answer? If I have 16 MB of main memory, how many MB can I put in the, sorry, how many process can I put in the main memory? Each process carries 4 MB.
4, sir.
4, yeah, exactly. So I can put 4 processes. If each process is going to spend p fraction of time during the IO, then what is the probability that all processes will do IO at the same time? Do you get?
Again, sir.
If each process is going to spend p time, okay, then what is the probability that all processes do the IO operation at the same time? What all processor meant is 4 processes.
P power
So
4.
p power 4, exactly. Okay. What is the fraction of time that CPU will be busy? Now the formula comes back to the old. What is the CPU utilization time? What is the fraction of time that CPU will be busy? That is nothing but the CPU utilization time. At this case, what will be the answer? The answer will be 1 minus p power 4. Okay. So roughly for this we will get how much we will get? 1 minus p power 4 means roughly we will get the utilization as 60%. This is not exactly. The process waiting at each process will be processor will be 60%. This is the when we improve the 16 MB and for each 4 MB data means for 4 processors this will be the answer, and for this CPU utilization 16% will be the processing time in the main memory. So then I am going to improve the 16 MB into more to 32 MB. Let us see what happens there. So main memory is 32 MB. and each processor same, because we are going to increase the main memory only, as 4 MB. Okay. So in this case, what will be the CPU utilization time? And before that, how many process will run inside this 32 MB? If 4 MB means how many process will be inside the, what is the P value?
8 processes.
8, sir, 8. Yes.
8 processes.
P value is 8 processors. This is just a simple calculation to make you understand. It doesn't mean that if main memory increases, the CPU also increases 100%. Okay. So now here we are going to calculate the CPU utilization time. Now time CPU utilization. It will be 1 minus 9 power 8. This will be, and it will be roughly 83%. It is roughly, not exactly. If you want exactly, you can. So as we increase the memory, the size and the number of processes in the main memory also increases, and the CPU utilization also increases. That we expect. Okay. So next, what we are going to see is we are going to improve this more to the more amount, main memory to the more amount. What we are going to fix the value? Main memory. Again, I am going to increase the main memory to 48 MB. And each, as usual, each process 4 MB. So here, what will be the P value? How many processes will be inside? Can I get an answer from you, so that I can find that you are listening and interacting? 12. Okay. 12 process can be present in the in the memory at the same time. And what will be the CPU utilization time there? One minus e power 12. So roughly it will be 93%. Okay.
So
Since
how you are calculating?
It is rough calculation. You can how to say, it is a rough calculation. It is the calculation what I am mentioning here is the rough calculation. For example, in the beginning, what I told, if the CPU P value is 80%, and the initially what I told before assigning the value for CPU utilization, 1 minus 2 is equal to 20% means the P value is 80% means the CPU utilization time will be 20%. From that 20%, we started to calculate. Do you understand? For example, in the beginning, I started the CPU utilization time. For example, the P value is 80%. Then the utilization time will be 1 minus P. It will be 20%. Okay. From here, I started the gradual improvement of the main memory, so that the process also will be increased. From that 20%, step by step, we are getting improved. It is so only I am telling it is roughly, not exactly. Okay. Here, if you want the exact calculation, means you need to put the value of the process exactly, and you need to do the calculations. Okay. And exact this is just to create the awareness for you that memory management will not, if the main memory increases, the CPU utilization time will not increase to 100%. For that, the mathematical solution I am telling, it's a mathematical explanation. It is not a solution. Okay? Is it clear?
Understood, sir.
It is not a clear and exact value. It is the rough value, rough calculation. See, if it is 8 processes there, 12 processes there, but the memory also differs. So roughly 80%, 93%. So here the percentage is only differing, but the level of the memory is more here. See 32 here 48. So level is more. Number of processes is also more. Okay. So likewise it differs. It is not the exact calculations. So the gain is not going to increase linearly with the increase of main memory. Why it is not going to increase means, see the increase of the okay, I will clear this. I will display you the main memory we have used and the percentage we achieved increased. Okay, the solution we are coming to know here is what I told you. It doesn't mean that when the main memory increases, 100% the CPU will not, or CPU also utilization will also get increased. So for that example only, I wrote these values and got the percentage. Now I will tell. It is the main memory 4 MB. First value we gave, and then for this for 4 MB, what we have fixed na? 20% CPU utilization. Okay. This process will be 4 each. That flows here. That is not necessary because the process number here. If we want, we can keep. This is the process number. And this we are going to double into 16 MB. We have done it, and I am putting into table. Okay. Here 4 process each. So how many process we will get? We will get 4 process. And the percentage we achieved is 60%. So you doubled the memory and you achieved 40% extra in the CPU utilization, and the process also increased. And now we are going to double it, 32%. Sorry, 32 MB of main memory. And how many process you are going to process it? 8 process. And what is the percentage you achieved? 83%. Okay. And then also we improved it. 48 MB. What is the number of processes? 12. And what is the improvement in the level? 93. This is CPU utilization. Okay, let us come to the conclusion now by comparing the 4 increment of main memory and the CPU utilization. See, here it is 100% doubled. Here you doubled. Okay, and here also you doubled the memory. And here what you did? You added 16 here. So you added the 50%. So you added 50% of the value here. It doesn't mean 50%, it is 25%. 25% increment you have done here. Okay, this is okay. And we can see here that you got a 40% increase, and from here to here, how many percentage you got? 23% only you got the increment in the CPU utilization. And here 83 to 93, only 10% of the CPU utilization. See, when the memory is keep on increasing, see, from here it got here. Each and every stage, it is not decreasing, it is increasing level only. 4, 16, 32, 18. But here the increasing level increase, but here increasing level decreases. From 20, 40% it increased. From 40, you have increased the double that 16-bit MB, you have 16 MB, you have data, you have increased, and the process also increased. Process capacity, not the process capacity also increased. But the increased level is only 23% performance increase in CPU utilization increased. And after that, here 12 process capacity increase, and this is 48 MB, and here only 10% increased. So from this, what you understood? From this, what you have understood? So if main memory, the number of process present in the main memory doesn't predicts the CPU utilization time. Okay. If the main memory, it is simply to say, if you increase the main memory, the CPU utilization will not be 100%. There will be some performance degradation. For that only, this calculation is shown to you, and you will be clear now. Theoretically, we may be comfortable that yeah, if I improve the memory, my system speed will be high, like that. But the speed will be high; it will not be 100%. See, someone can say 100%. If I have infinite main memory, means my CPU utilization will be 100%. That never happens. It is not going to happen at all. Are you clear in this concept, right?
Yes, sir.
Okay. Okay. Now from this, we can come to the formula that means the gain is not going to increase linear with the increase of the main memory, as I told you. The CPU will be the total number of the processors. Then CPU utilization will be this will be the final formula for CPU utilization. You can note it down. It will be useful for you in future. So yeah, P power n. This is what n is meant for, means n denotes total number of process in main memory. Fine. Okay. The number of processes present in the main memory is the degree of multiprogramming. So you will come next. Will be identifying the degree of multiprogramming. What will be the degree of multiprogramming? Means the number of processes present in the memory is called as the degree of multiprogramming. As we told, I displayed you the table that 1, 4, 8, 12. Okay, these are the number of processes in main memory. This is called degree of multiprogramming. Multiprogramming. The handwriting will be a little bit horrible. Please assist. Okay. Therefore, the CPU utilization depends over the degree of multiprogramming, because this is the degree of multiprogramming. Nothing but p value, as I told you, it is the fraction of time from which it is going to work in the IOU. This is the fraction of time where it is going to work in the IO. Here, in this case, you can apply the value and take the answers. And n is the, if we increase the degree of multiprogramming, the CPU utilization will also increase. If we increase the n value, the CPU utilization also increase. As what we did before, means here we increase this value to 1, 4, 8, and 12. So the CPU utilization also increased. This is the conclusion. Where the p value is the number between 0 and 1, because it is the fraction of time which it is going to work on the IO. So what we are going to do, if we now what is our main goal in this memory management? My main goal is to achieve 100% CPU utilization. If you want 100% utilization, you can have as many as possible main memories, but it is only possible when you have lot of main memory, then only we can have a lot of processors. Infinite main memory is not at all possible. Is it possible to have an infinite main memory? Because if you buy a laptop, the laptop cost depends upon the processor and also the memory also. So memory is that much costly. So if you have infinite main memory, means your cost of your laptop increase. Obviously, for any infrastructure, If the memory increases, the cost also increases, then it will be very tough for the affording the system. So the purpose is, if a simple purpose is occupying more number of memory, means that is useless. Okay. So by having infinite number of main memory, we should increase the degree of multiprogramming. How to increase? It is impossible to do that. So how it is possible? So what we can do is, we can use the memory in such a way that it mimics or it acts as the infinite. So memory I am having, I no need to make it as infinite. But what can I do is, I can make it to act it as infinite. So how I can do this? This is costly, and this is not cheap, it is affordable only. Affordable plus techniques. What are all the techniques? So this can be achieved. This cannot be achieved. This can be achieved. That is memory management. Okay, hence a lot of issues will come in this picture. By using memory management techniques, we can achieve it. What are the issues we are going to face? And the solution for that issues will be the content of the upcoming classes. Okay. So by using memory management techniques, that mimic of the main memory as infinity is possible. Okay, it is possible. So to make this possible, what are the problems we have? Hence a lot of issues will come into the pictures. Okay, first, lot of issues will come. Will come while trying to mimic. Okay, that's fine. And second is, how much memory you are going to allot for each process? That is the question. Allot for each process. Okay. How are you going to allot? Okay, how much? And you can shortly write it. How are you going to do? It has some techniques. It has some techniques. How are you going to allocate? Because first of all, how much memory you are going to allocate, and how are you going to allocate, and how are you going to deallocate? This thing, allocation and deallocation, I will tell in the end. And how are you going to provide the protection among various processors? So security comes here. How are you? Who are you going to give? Protection. For various processes. It is just the introduction, so don't feel that you don't have the material. You need to be aware what you're going to study in further classes. For that only I am taking this steps. Okay. So first things, a lot of issues will come while trying to the mimic. Okay, these issues we will face by seeing the by taking some other techniques. Okay, and how much memory you are going to allocate for each process. This memory allocation. Okay, how are you going to allocate? How you are going to do this? And if you allocate, how you are going to deallocate it? And the third, last thing is, how are you going to give the protection for various processes? There is various processes in memory. You need to give the protection for each. Okay, and at that time you need to go for a memory management technique. And coming to the allocation and deallocation, in traditional way, allocation means it is a one-time allocation. That's it. You cannot use that space again. If you want to use that space again, you need to clean it and assign the new address for it, and then only you need to reuse it. But nowadays we are accessing memory then and there by using different techniques. That is called the allocation and deallocation. If you allocated a job 1, job 2, job 3 means, if job 2 goes outside means, automatically this place will be filled by job 4. Like that, allocation and deallocation is very much important. And as of now, I will stop with this. This is the short introduction for the memory management technique. Okay, guys, are you there? Guys?
Yes, sir.
Okay. Stay online. Couple of minutes, I will come back.
Guys, are you there? Anyone respond?
Sir.
Yes, sir. Okay, fine. And I would like to ask some students. Karan, are you there? Karan? Karan?
Yes, sir. Yes, sir. Yes, sir.
Okay, do you have any doubts?
No, sir.
In the memory introduction, is it clear?
Yes, sir. It is clear, sir.
Okay, that's fine. And how you feel about today's class? Do you have any suggestions?
It is okay, sir. It is nothing to complain.
Okay, that's fine. I didn't ask for the complaint. If you have anything, means you can ask me in this group itself so that I can improve it in the next class. That's all. This is an online teaching mode, so everything should be interactive. If you miss to communicate with me, that message will not be conveyed. If you are sitting in front of me, I can see your face and predict something. Yeah, he understood this. I didn't understand this, like that. But that communication gap is there, so we need to fill it back. Okay. Thank you for the feedback. And Jagannath, are you there? Jagannath. Jagannath, are you there? Okay, that's not that. I can ask someone else. Deepak or Deepak. Deepak. Some students I was calling for past few days and they were not at all appearing. I think they switched on their class and they went for some other work, I think so. Deepak, are you there? Okay. Shyam Sai, are you there? Chipala Shyam Sai. Oh, business. Shamsa, if you have any doubts or you need any clarification, means you can text it so that I can read your test and respond you. Bhavatarani. Shamsa is listening to things. Okay, that's fine. Bhavatarani, are you there?
Yes, sir.
Okay, do you have any doubts?
No, sir. No, sir. No doubt.
Okay, that's fine. And can you please summarize what I have taught in this memory management introduction? Just summarize it to 2 to 3 points. That is enough.
The basic, what are the needs of memory management? Why do we need about the memory management, as well as some concepts like it is,
in simple word, you don't need to tell the entire content. You can simply tell what you observed, what you saw in this introduction, what you observed. So it is not necessary that we need, if we increase the main memory, it will improve the CPU utilization to 100%. It is not necessary, right?
yeah,
For that only we gradually improved the main memory and we calculated the CPU utilization time and we compared it. And what are all the problems will occur while improving such? See, improving the memory means immediately we won't get the output. Okay, we need to solve the problems which occurs. Okay? And that is not only the solution, because infinite memory is impossible. So for what other step, for what we are going, say we can't improve the memory. So for which process we are going? Can you tell? Bhavatarni? Are you there?
Please repeat the question, sir. I can't actually understand what it means.
Okay, we can't improve the memory to infinity. Okay, the other step, I need to achieve the CPU utilization to 100%. So for what step we are going? What will be the solution to that? It's very simple. We are going to mimic the memory, right? We are going to mimic, as memory is huge. What, for example, we can say the virtual machine. Okay, it is going to mimic the memory capacity into several stages, and we are going into. It is going to give us the fast access, right?
Yes, sir.
Yeah, that concept only is mentioned here as a mimic. We are going to mimic the memory as infinity, so that we will have. We can do process many number of processes and improve the memory level, and we can achieve the efficiency of the CPU utilization. Okay, thank you, Bhavatarni. Thank you for the answer. And guys, if you have any doubts, you can ask me. And regarding the feedback, anyone can tell anything. I'm ready to clear your doubts. Okay. Feedback means I will change whatever the things required. Okay. And afternoon at 3 o'clock, you will be having the CA2 exam, and completely you will be having the test from the module 2 to get prepared for it. And I would like to ask Sabri Ganesan. Are you there? Sabri Ganesan.
Sir, yes, sir.
Okay, Sabri Ganesan, can you tell in module 2 what are all the CP scheduling mechanism you have tried with?
In model 2, sir, scheduling.
Yeah, in CPU scheduling, what are all the different types of scheduling algorithm you have worked on with?
Round robin.
Okay, then
FCFS.
Then
first come first serve. Then shortest job first.
Then
shortest remaining time.
Then
yes, sir. That's it.
That's it.
Yes, sir.
Okay. And thank you, Sabri Ganesan. Yeah. Manoj, are you there? Manoj. Manoj, are you there? Hello? Lingesh Kumar, are you there? Yeah, Linkesh, what are the scheduling algorithms available in the module 2? What are the scheduling algorithms? Scheduling techniques.
Round robin, SDF, FFFH, and priorities.
Okay. Have you practiced all the problems?
Practice.
Everything. Okay, fine. And can you say what are the process synchronization techniques available?
One minute.
Yeah. You check it and tell.
The shared memory. It is shared memory mutually. Sir, can I see you? Sir, semaphore solutions and using semaphore and bounded buffer problems like this.
Okay. And that's fine. And these are all the techniques, okay. And what are the problem solutions available for the process synchronization? Already have solutions.
Read and write a problem. Dining philosophy. I forgot that
Okay,
name.
fine. Okay. You can think it and tell.
And bounded buffer problems. It is also another problem.
Okay, fine.
I think that's all, sir.
Okay, that's fine. Thank you. And students, today's assignment I have posted in a Google Classroom that the process. Linkesh, thank you. You can mute yourself. Yeah, thank you. And assignment I have posted in Google Classroom. That is nothing but the process commands in 30 process commands in Linux. You can try it and you can take the screenshot of those results, and even you can give the explanation of each and every command. If PS it is there, means you can write PS is for showing the process running behind the system. Like that, one line explanation you can describe. It should be how means in your assignment. First, you write the 30 commands and write the explanation of each and every command. And after that, you put the screenshot of those commands which you have implemented, so that I'll be sure that you know the explanation and you have implemented the commands. Okay, is it clear? Vishal Shivakumar, is it clear? Vishal Shivakumar. Is no there? Manoj. Okay. That's fine. It's time up already 12:15. You need the time to do the assignment and need to prepare for the exam also. And sharply at 3 o'clock, you'll receive the question through the Google Classroom, and you should write. Okay, Vishal is clear. Okay, that's fine. You should write your unique ID, subject name, unique ID is necessary, and you should save the exam paper in your unique ID only. Because last time some of them saved in different names, so it will be difficult for us to evaluate and put marks because everything is online and digital document. Everything is digital document, so we can miss. Okay, if it is your roll number means we can identify easily your number. So for your good sake only we are telling, save your document in your unique ID. Okay, in your paper your unique ID should be there. And at 2:55 itself we will try to upload the question paper, so that you are telling that you are receiving the question paper late. So this time we will upload the question paper in advance, so that you can get the question paper at exact time, or in advance itself we can get. Okay, and at 4:15 the exam will be over. Try to complete the exam on time. For each and every late submission, we will get a record that specific student submitted the document for 10 minutes delay, like that it will become 10 minutes delay, like that it will come. Or even 1 minute also it will show separately. Some constraints will be there. It is not 100% restricted. Okay, some constraint will be there, but more time we cannot allow. We will not evaluate that paper, and mark will not be provided, and you should not feel that I did very well but I didn't get mark, like that. You should not feel, because it is a test. We should follow the timing. Okay, for some constraints we can allow, but we cannot allow for more time. So be aware of the timing. Once the test started, you should start immediately, and before the ending time you should try to capture the screenshot and format it and try to submit before the ending time. It will be good for you. You see, if you see the document which is submitted in the exact time means, it will be happy. We can't stop anything in that. Okay, so try to keep up your time. Okay, go and sit in a place where you are getting a good network. Don't blame on the network. Okay, we need to find the solution. Why you are sitting in the problematic area? Okay, guys, all the best for your exam. Prepare well, complete the assignment and submit the assignment. Today's assignment process commands in Linux, and all the best. See you exactly at 2:55. Have good lunch. Bye.